What's the relationship between linear regression and binary logistic regression?
Regression models use a function that depends on a number of coefficients to describe the relationship between a dependent variable and one or multiple independent variables. Once the coefficients are calculated, this function is used to predict the value of the dependent variable given a set of independent variables. Linear regression models the value of the dependent variable directly, using the linear combination of the independent variables. Binary logistic regression, on the other hand, models the probability for one of the two classes. Therefore, logistic regression is used to solve classification problems and linear regression for numerical predictions. What both algorithms have in common is the minimization of an error function to find the coefficients that best fit our training data.
How can I interpret the coefficients of a linear regression?
There are two ways. We can either interpret the sign or the value of the coefficient itself. The sign of the coefficient tells us whether there is a positive or negative correlation between an independent variable and a dependent variable. A positive coefficient means that if the value of the independent variable corresponding to that coefficient increases, then the predicted value of the dependent variable increases as well. On the other hand, if the coefficient is negative, the predicted value decreases when the value of the independent variable increases. In addition, we can also interpret the value of the coefficient. It tells us how much the predicted value changes if the independent variable increases by 1 unit while keeping all the other independent variables unchanged.
How do I know which of the independent variables is actually important?
A common way to estimate the importance of an independent variable is the p-value. A p-value is the result of a null hypothesis test, testing whether the coefficient is equal to 0. A low p-value indicates that the null hypothesis can be rejected, which means that the corresponding independent variable has a significant impact. High p-values, on the other hand, indicate that the corresponding independent variables are not likely to add meaningful information to the model and can be excluded. A commonly used threshold for the significance level is 0.05.